Alright, so now we come to a system of three equations with three unknowns, and we want to solve it very much the same way that we did numbers 1 and 3. We're trying to eliminate a variable. And ideally, we would be able to eliminate two variables at the same time. That doesn't look to me like it's going to happen here. And so what you do is you're going to pair up these equations, and we're going to use all of them, okay, which means one of them we'll use twice. For example, we can pair up these two equations, and I think that's probably what most people see first, is that if we add these two together, 2x plus negative 2x, no more x's. Negative y, we're adding these. Negative y plus negative 4y, negative 5y, negative 3z plus z, negative 2z, 12 plus negative 23, negative 11. Okay, so what have we done? We've eliminated the x variable. How does it happen? Help us? At the moment, it doesn't, because we have two variables still and only one equation. But if you will now go up to, we're going to do a different pair. If we were to pair up these two equations and eliminate the same thing, that's very important. You have to eliminate the same thing. If we eliminate x on one and then y is on the other, that doesn't help us, because we're going to have two equations that come out of that, and they'll have three variables total, which we can't solve. We need two variables, and those variables we've decided are going to be y and z. Side note, I think it would be easier to eliminate the z's. You would multiply by smaller numbers, but you can do it both ways. So I think this is what most people see first. All right, so we have chosen we have to eliminate the x's. So what is the smallest number x's coefficient that could be in front of the x's that would be the same for both? Well, if we multiply the top one by 2, we would get negative 14x plus 14y plus 4z equals 70. Multiplying the bottom by the opposite, or the other one, we multiply this one by 7 because we want this to be 14, right? We get 14x minus 7y minus 21z equals 84. Multiply all of those things. And now we're ready to add these up. That becomes 0x, 7y, negative 17z equals 154. Alright, so we now have two new equations, one here, one here. Alright, so we're kind of setting aside the original, and we're taking our two new equations and we're going to treat them like a system where we want to eliminate something. And you can kind of see that this is getting a little bit cantankerous with the numbers. So what are we going to do? If we want it, we can eliminate y, or we could solve for one of these variables and do substitution. I think you'd find that to be messy. So I'm going to try to line up the y's, which means I need to multiply this equation by 7, and I'm going to multiply this equation by 5. So this one's going to become 35y minus 85z equals 770. Yeah, I think that's right. And then over here, we will have negative 35y minus 14z equals negative 77. So then we bring these two things together, and we're going to eliminate. You can probably do this a little without taking up quite as much space on your paper, but y's cancel out. We add these up. That is negative 99z, and then Negative 77 plus 770 is 693. When you divide 693 by negative 99, like so, you get the first variable. Z is negative 7. Good for us. So what do we do with it? You take it back to one of these equations, here or here, and plug in what you know. So I'm going to do it with this one on the left because it's got smaller numbers. Negative 5y minus 2, what's z? Negative 7 equals negative 11. Negative 5y plus 14 is negative 11. Negative 5y is negative 25. Y is 5. Just divide by negative 5 on both sides. Okay, so we're almost done, which is good because we are extremely close to being out of space. And we just have to find x. I'm going to use this equation right here to find x. It says negative 2x minus 4y, y is 5, plus z, which is negative 7, equals negative 23. Negative 2x, that's negative 20 minus 7, negative 27, equals negative 23. Negative 2x is equal to 4, x equals negative 2. So again, you write your final answer as this time as an ordered triple. It's 3 variables. So x, negative 2, comma y, 5, comma z, negative 7. And that's your solution.